everybody. Today we'll be covering what is Docker Compose, how to set up your Docker Compose file, as well as how to run that file to fire up all your containers. If this is your first time using Docker, I highly recommend you to watch my previous video on how to install Docker and how to create and run a Docker image. Link for both of those videos will be in the description below. Just as a brief summary though, Docker allows us to containerize our applications so that they can run independently from one another, only using the specific dependencies that are required to get each portion of the application going, as well as ensure that this application works in various different environments. With that being said, in our last video, we created a Docker image to run our React application. However, what if we had multiple containers? Say we had one container for our backend, another for our front end, another for the database, maybe let's just say one for Nginx. Then all of a sudden, to get our application going, we would have to manually run all these separate containers. And then once we're finished and want to stop our application, we'd have to again manually close down all these containers that we created. This is where Docker Compose comes in. It allows us to run multiple containers from a single file. It links them all together for easier communication between the containers, and it allows us to specify any particular configuration for each container, so we do not have to type these in every time we start our container. We can basically start our application with one command, and then once we're finished, we can close and clean up our application with one command as well. As you can kind of imagine, this is incredibly useful and very powerful. And we can first see that we're inside the React application we created from our last video with some minor changes. If you guys would like a reminder on how to set up your React application, I do also have a video for that and it's in the description below. So we can see we made some simple changes to it. Now, instead of our React application being the only application in this environment, it's in a separate folder called client. And then we have another folder for our server, in which we can imagine we have our index.js file, which contains our server file. This is a very simple application. And we can see here that in our app.js, we render a button with the name of ping. And when we click on it, it comes into our click handler, in which we, with the help of Axios, send a request to ping, and then it outputs whatever we get back from our server. So in this case here, if we open our server file for index.js, we just have some boilerplate to set up our server with Express. And we actually have this path variable in here, which isn't really needed, so let's delete that. And we can see here that when we get a request for ping, we're going to send back a request that says pong in the message. And once we get back that request pong from our server, we're going to console.log that. We can imagine this to be any form of request in a real application, but with this setup, we can clearly see that our front end needs to communicate with our back end for our application. Now that we understand how our application works, let's take a look at the Docker files. So let's open up the Docker file inside of our client folder. And the Docker file for the client application is the same as the one in the last video. So just to briefly go over what it's doing is we can see that here that we're using our base image node with the latest distribution of Alpine, which is a lightweight Linux distro. We change into our directory called application. We copy over all the package.json files into our container, and then we run yarn install. And the reason we do this before copying over the rest of the contents of our container is so that we can have a layer with our node modules already installed in our Docker container. And this is basically for faster image building in the future. If we can imagine whenever we're deploying or building an application, we are more likely to change the source files than we are to add in a new dependency. So if the dependencies are the same between our current build and our past build, it's going to take this cache from the previous layer and it's not going to have to build it again. And that's why we run these separately. So finally, once this is run, we copy over the rest of the contents in our folder into our application, and then we run the command yarn start to start our React application. And then we have a very similar setup for our Docker file in our server folder. If we open up that Docker file, let's get that again. If we open up our Docker file, we can see it's pretty much exactly the same thing, except now we are moving it into its own work directory called app server, and inside of there, we are then running the command yarn dev. And then dev, in this case here, responds to a script that we have set up for nodemon, and it's going to run nodemon index.js. And the reason we're running nodemon here is because during development, if we make any changes to our index.js, without nodemon, we'd have to restart our server every single time. What nodemon does is anytime we make a change, it restarts the server for us, and this is great during development. Now, with all that being said, let's look at what the workflow is to get our application up and running. So, ls here, we are inside our client folder. So let's create two terminals because we have to start up our server and have to start up our front end. So this first one here, let's change directory to server. And let's spell that correctly. Now we can just start here and do yarn dev. And then over here, we can do yarn start because we're in the client. And there you go. Now this is starting our local host. And we can see here, just like we mentioned, we have a button here called ping. When we click it, we get back a message with the data pong from our server. Perfect. Everything is running as expected. So over here, we have to set up both of our applications separately. So let's close them down again. Now, what would it look like to set up both these containers? So we'll first check to see if we have any containers, or images, sorry. Great, no images. Let's see if we have any stopped containers. So we have no containers, no stopped containers, and no images. And that means first we have to build the image in each one of these folders. So right here we're in the client folder. So we can build our front end by typing docker build, tag T for the name of the tag. In this case, let's call our container front end. And then we're going to build it here. Okay, so that built the image for our front end. Now let's change directory to server, and let's do the same thing here. Docker build tag T backend. And let's open up a separate terminal window so we can both have these running together. So now let's make this right hand side being the server, and let's make the left hand side be client. Now to run both of these containers, let's start by running the client container. Right, we'd have to do docker run. We have to specify which port it wants to speak to, in this case 3000, because that's the default port for React, and 3000 again on our port it corresponds to, or sorry, the containers port it corresponds to, and we want to run the client image. And that's because we didn't call it client, we called it front end. So now it's starting that container. And now if we do the same thing here, docker run, tag p 4000, because that's what we said our server is listening on, and then we say backend here. And now it's running both of our containers. Our application is now successfully deployed. But let's see if it actually works. We're here. If you refresh the page, great, it's working. So our containers are up. But what happens here if we press ping? And oh, look at that, it fails. And the reason it fails is because we look over here, our containers aren't actually speaking to one another. We got this rejection because we are proxying to localhost 4000, right? If a request can't be found in our server, we are saying in our package.json file to go look at localhost 4000 to answer those requests. The client is looking for localhost 4000 inside of its own container, and in that case there, it's not going to find our server running there. So we actually need to link these containers up together so they speak to each other. So you can imagine this is already getting very annoying. We have to build both of our images separately. We have to pass in all these flag variables and the correct image names. And now for situations like these, we actually have to link them together. So this is where Docker Compose comes in, and it allows us to set up and tear down our application with a single command. So let's get started by stopping the containers we had running earlier. So if we do, and if we do docker ps, we can see here that we have these two containers still actively running. So let's just stop BA and C0. And there you go. We have now stopped both these containers. And if you look at docker ps, there is nothing there. However, these containers are still stopped in the background, but we want to remove them all together to properly clean up. Docker remove BA and C0. And the reason we're doing this is because the container IDs here start with BA and C0, and as long as we specify unique match here, it'll remove those containers in question. So now when we do docker ps, there's nothing there, but when we docker ps tac a for stopped containers, there's nothing there as well. So that's another thing that our Docker Compose file is going to help with, is to help with this cleanup process right here. And right now we only have 2 containers, and we can imagine if we had, let's just say 5 or 6, this becoming extremely difficult to do and almost to the point of becoming impractical. So how do we get started? Well, we first get started by creating our Docker Compose file. So let's come here outside of these 2 folders and make a new file here called Docker Compose.yaml file. So inside of this file, we want to specify a version, and this is gonna relate to the version used for our Docker Compose file. And we're going to use version 3 because it's relatively recent and it includes pretty much all the features we want to use. And then we can start defining our services. And actually, before we do that, let's just exit out of here so we have a little more space to work with. So what are services? Services can be thought of as the separate containers that we are going to set up and run. So in this case here, let's start off by setting up our first container, our server, right? And now this is going to be all the configuration files to get our container server up and running. So the first thing we want to do is we want to build our container. So to build our container, we have to specify where we can find the Docker files for these containers. So in this case here, for the server container, we can find it in context, inside of the server folder, and the name of the Docker file is going to be Docker file. So we want to run the command yarn dev every time we start this container. So let's just pass it that command. And this is going to start our server in development mode, so with nodemon behind the scenes. Then we want to map our ports 4000 to 4000. 4000 on our local machine corresponds to 4000 on the container. Finally, then we can even specify volumes. So changes we make in development, we read immediately by the container. So volumes, right? And then we want to say inside a server and app server read only. And if some of this stuff you guys need a refresher on and what exactly it means, please watch my previous video where I cover the volumes, ports, commands in detail. Then we can name our container. So let's give it a name. Container name is backend, and let's name the image that's created here. So the image can be server. So it's going to build this image called server, and then it's going to use this image to create our container backend. And now our client service, or our client container, is going to be very similar to this. So let's actually just copy and paste this here. And let's come back, and now let's make this client. In this case here, the build context is not going to be the server folder, it's going to be the client folder. We're not going to run yarn dev, we want to run yarn start. The ports are not going to be 4000 to 4000, they're going to be 3000 to 3000. And our volumes is going to be slightly different as well too. And our volume is going to be client source, and we're going to map that to app client source. And basically what we're saying here is any changes in the source folder should be read from our local machine during development, and this will make all the changes be very quickly. We don't have to respin up our container every single time we make changes. Finally, let's call our container name be frontend, and then our image name be client. And then one more thing we should specify is our client should only start running after our server runs. So let's do that. Depends on server. So what this means is now our client is going to boot up and run first, and once that is done and set up, then our server will set up and run. So once we have that done, we need to make a small change in our application. Earlier we were proxying localhost, so if we open up our client and we open up the package.json, we can see here that we are proxying localhost, meaning that whenever we couldn't find the request localhost 3000, we're going to forward it over to our server on localhost 4000. But in this case here, inside our container, it's not going to be localhost, it's going to be the name of the service we define. So in this case here, we defined our service as server. So we come here and we say forward any request that we can't define to server. And now let's open up the terminal. And now to basically run our application, all we have to do is docker compose up build. And this is going to build our images, and then it's going to run the two containers. So that took about less than a minute to build our images and start our container. And we see it's running on localhost 3000. So let's take a look. Come up here. Let's refresh. Okay, great. And if we type ping, we click the button ping, and we get back the data pong. Voila, we set up our whole application with a single command. And now to shut down our application, all we have to do is let's just exit out of here. And now it's stopping all the containers. And now to clean up, we just do docker compose down, and it removes all the containers for us. And now when we do docker ps, right, nothing is running. And docker ps tac a to see all stopped containers, nothing is there either. So we have set up our application with a single command, and we have now shut down our application with a single command. So just to overview what we went through today, we covered what is Docker Compose, why we use it, how to create our Docker Compose file, and how to run it so we can set up our application with a single command. If you guys found this useful, please consider giving this a like and subscribe, and then see you guys next time.